Hi and welcome to today's video. Today we're going to talk about solving quadratic equations by completing the square when a is not equal to 1. So before what we talked about is when a is equal to 1, we can solve using completing the square. Now we're going to expand on that a little bit and allow for a to not have to be 1. And really, so what I've done here is I've taken the steps that we talked about before for solving when a is equal to 1, and I just added one little sub-step here. So remember, move the constant to one side of the equation, or basically get the constants on one side and everything else on the other. And then what I'm going to suggest that we do, and this is probably the easiest way to handle this, you might see other ways shown to do this, where you just factor out the a and deal with it that way. But this way will work for since we're solving. Just divide everything by that a term. So for example, if our a term here is 2 in front of the 2x squared plus 4x equals 9, if we just divide everything through by 2, we would end up with x squared plus 2x equals 9 halves. And now we would just solve that just like what we did before when a was equal to 1, because we have basically now forced a to be 1. And so it will solve just fine in that method. Okay, so let's look at a couple of examples of that here. First one, 5x squared equals 6x plus 8. So I didn't show any examples like this before. I just had either everything on the left or maybe just a constant on the right. Here, instead of moving the constant over here, since it's already over here, we just need to move the 6x over to the other side so that we isolate the constant. So this is still step 1, subtracting 6a from both sides to make it 5x squared minus 6x equals 8. Okay, and so that's that 1a step where we get rid of the a value. We're just going to divide everything through by 5 to get rid of that 5 in front of the x squared. So when we do that, we divide here by 5, we get x squared. Dividing here by 5, we get negative 6/5 x. And when we divide here by 5, we get 8/5. Okay, so now it's not quite as nice to work with because we have this fraction to deal with. So we have to think about, well, what is half of b? And then we have to square that number. So over here on the side, if we take 6/5 and divide it by 2, that's essentially 2 over 1, we're dividing two fractions. And remember, when we divide two fractions, we keep the first fraction, change the sign to multiply, and then flip over the second fraction. So this is really 6/5 times 1/2, which is 6/10, and we can reduce that to 3/5. So our b over 2 is 3/5, and that is the number that we would need to square. So 3/5 squared. And we're going to add that to both sides in step 2 of this process. So we get x squared minus 6/5 x plus 3/5 squared. And over here, I went ahead and squared that 3/5 to make it 9/25. Okay, so now, of course, to add these, we do need a common denominator. So I multiply top and bottom here by 5 to get 40/25. And I did go ahead and do step 3, where we factor the left side and write it as a perfect square. So we end up with x plus 3/5 squared equals 40/25 plus 9/25. And if we combine 40 plus 9 on the top, we get 49/25. And so now we can go ahead and take the square root of both sides, just like what we did in the previous one. Same steps from here on out. So when we take the square root, remember, put plus or minus here. So we get x plus 3/5 equals plus or minus square root of 49 is 7, square root of 25 is 5. So x plus 3/5 equals plus or minus 7/5. And now for step 5, subtract this from both sides. So subtract 3/5 from both sides. And we get x equals negative 3/5 plus or minus 27. So plus 7/5, or sorry, plus or minus 7/5 is what I meant to say. So negative 3/5 plus 7/5, and negative 3/5 minus 7/5 over here. And negative 3 plus 7 gives us 4 over 5. And negative 3 minus 7 gives us negative 10 over 5, which is negative 2. Okay, so same process except for this one little modification right here. Okay, we'll do a slightly more complex example here. Negative 4x squared plus 5x plus 24 equals 0. So remember, step one is we need to get the constant over to the right side. So we're going to go ahead and subtract 24 from both sides. So we have negative 4x squared plus 5x equals negative 24. And that step 1a, we're going to divide by this a term, which is negative 4 in this case. So negative 4 divided by negative 4 gives us the 1x squared. 5 divided by negative 4 we'll just leave as negative 5/4. And negative 24 divided by negative 4 is positive 6. And so we have to find, for step 2, we need to find half of b and square it. So half of negative 5/4, once again, I've shown you here, negative 5/4 divided by 2 is negative 5/4 times 1/2, which is negative 5/8. So we have 5/8 squared here. Remember, if we square the negative, it's going to be positive. That's why I didn't put the negative sign here. And so 6 plus 5/8 quantity squared gives us 25/64. And so at the same time I went ahead and wrote this as something over 64. I just multiplied 6 over 1 by 64 over 64, which gives us 384/64. Okay, on this side I went ahead and rewrote that like we do in step 3, rewrite it as a perfect square. So we have x minus 5/8 quantity squared equals 384/64 plus 25/64. Okay, now go ahead and take the square root of both sides. So I did simplify here. 384 plus 25 is 409 over 64. So taking the square root of both sides, we get x minus 5/8 equals plus or minus the square root of 409. And the square root of 64 is 8. So that's why I wrote it as just 8 on the bottom and not as square root of 64. Okay, now go ahead and add 5/8 to both sides. So when we add 5/8, we get x equals 5/8 plus or minus the square root of 409 over 8. And then, so go ahead, step 6, rewrite it as one fraction. X equals 5 plus or minus square root of 409 all over 8. And there is our answer. Notice it's not a nice answer. It's an irrational answer, which you would not be able to find by factoring. And so this is how you would find those sorts of answers without factoring. Okay, in my last example here, I am going to go ahead and rewrite in vertex form. One problem for you. So there's a few modifications that we have to do to rewrite in vertex form. So in our example, y equals 3x squared plus 30x minus 5. Okay, so when we rewrite in vertex form, remember what's inside here is just 1. So we have to pull out this a value and have everything else inside parentheses here. And remember, when we're rewriting in vertex form, we take this constant and move it over so it's outside the parentheses. And we want to rewrite this as a perfect square. So of course, we're going to take half of b and square it. So half of 10 is 5. 5 squared is 25. But here's the thing. We're not really adding just 25 here. We're really adding 3 times 25. So when we subtract it over here, we have to subtract 3 times 25 because of this right here. Okay, so we're really, even though we're adding 25 in here, it's really 75. So we have to really subtract 75 on the outside. Okay, so we have 3 times the quantity x squared plus 10x plus 25 minus 5 minus 75, which will simplify to minus 80. And then we'll go ahead and rewrite this as a perfect square, x plus 5 quantity squared. So our final rewritten in vertex form is 3 times the quantity x plus 5 squared minus 80. Okay, just a couple of reminders. Remember that if we have to find the vertex here, the vertex is at it's at hk. I wrote negative h, but opposite of this, whatever that may be. So because it's x minus h plus k. So x the h would be -5 here, and the k would be -80. So our vertex is at -5, -5, -80. And if we're talking in terms of transformations, where is this graph going compared to the graph of y equals x squared? Well, it's going left 5, it's going down 80, and we have a vertical stretch, remember, hanging out here, vertical stretch by 3. So you might see a few problems where you have to do either writing what the vertex is or writing the transformations. Okay, so that's all there is for this particular concept. Remember, if you have any questions about what you've seen here today, be sure to ask in class. And always, thank you for watching and have a great night.